Professor Jack Ellis obtained his PhD degree in 1965 in electrical engineering from Michigan State University under the tutelage of Professor Hermann Koenig, father of physical system theory. Professor Jack Ellis went on to be the supervisor of Professor Satsangi at Waterloo for his doctorate in electrical engineering in 1969 on the topic A Physical System Theory Modeling Framework Generalized for Large-Scale Economic Systems. Today, we can only imagine those heady days at Waterloo when these renowned personalities must have worked together. It is a great honor for DI to have with us Professor Jack B. Ellis as the chief guest and inaugural speaker. Professor Ellis earned his bachelor's degree in electrical engineering from Toronto University and master's degree in control systems from Imperial College London. He went on to do PhD in systems theory from Michigan State University, and in his over 40 years of academic career served in various universities including University of Waterloo and York University, Toronto. Dr. Ellis took early retirement in 1996 from York University and is now Professor Emeritus. He has acted as a consultant to a wide range of projects involving park planning and tourism development, social, economic, and environmental impact of park development, highway construction, and recreational boating, among many others. He has published articles and papers on recreation and energy, urban open space planning, computers in design and planning, energy prices and transportation, and trends in leisure. His areas of academic interest are tourism, recreation and leisure, northern development, computer modeling, planning techniques, urban and regional planning methods. York University has instituted Jack Ellis Achievement Award in his honor for best all-round combination of academic achievement and extracurricular activities. Professor Ellis has been a great friend of our university and society and has enraptured systemic audiences at DEI by delivering 2 video talks at Paritantra 2008 and 2009, the first and second student systems conferences organized at DEI in March 2008 and February 2009 respectively. Our excitement knows no bounds as we have Professor Ellis with us today, and we are eagerly waiting to hear the guide of our guru or mentor as the inaugural speaker of this lofty conference. Professor Ellis, please.
But good morning to you all, ladies and gentlemen. To revered Professor Prem Saran Satsangi, I want to extend my very warmest personal greetings. They're undiminished after so many years. Of course, thankful greetings to Professor Das and Professor Kalra. Of course, honored guests, all of you presenters and delegates, and particular thanks to Dr. Vishal Sani for his amazing organizational abilities and helpfulness. It's certainly a pleasure as well as a privilege for me to be addressing this auspicious conference today. Now, in preparing this inaugural address, I recalled a bit of wisdom imparted to me fairly early on in my academic teaching career by a wise mentor. And he said, to make a good lecture, you need a good beginning and a good ending, and then you should put the two as close together as possible. Now, I'm afraid I shall fall short of that ideal today, but I hope that any points I might leave out, you can pick up at your own convenience from the proceedings. Now, also, when I was informed of the topic, or the theme of this conference, Systems Paritantra for Better World Order, I was immediately intrigued and motivated to make it as the title of my paper as well. It's certainly a great challenge to ponder whether an all-encompassing general systems theory really could contribute to realizing a better world order. Of course, the answer that I'll have for that question is yes, but I shouldn't tell you. Now, when we look at our world today, we see so many places and in so many ways the severe disorder that exists in the world. Economic systems are in disarray. There's such disarray that governments have had to intervene in unprecedented ways and in concert. The damage started in the United States but has spread so that many, if not most, developing countries have received collateral damage as well. The natural environment is being stressed beyond its capacity. Hard to sustain healthy human communities and natural ecosystems. Worldwide pollution of the atmosphere and the seas has been a result. The global climate is shifting. We're now having icebergs approaching Australia, for goodness sakes. The Arctic and the Antarctic are warming at rates that were inconceivable even 2 years ago. Many areas have unprecedented droughts, while the others are swimming in floodwater. Most societies are being stressed from growing population, shortages of essential resources, even water, as has been noted. And just think, population at the moment is still growing approximately 3 times faster than agricultural production, than food production. And in future, we're going to have to grow more food on less land with less water. Some of the land is becoming unsuitable for agriculture because of salinity and other factors. The values of many societies are being eroded, shall we say, by things like instant communication and high mobility that our present technologies are fostering. What we are also very worried about, of course, are armed conflicts. They're still going on. They're not usually at the national level. We're a bit beyond that now, we hope, with our fingers crossed. But the incidence of damage by extreme fanatics is continuing. Now, if we're faced with such a world situation, we have to ask ourselves, how could it be made better? More important, what can I do to make it better? Can the efforts of one person, one group, or even several nations working together in concert be sufficient to instantly transform the present world into a better one? Perhaps not. But that doesn't mean that individual efforts are in vain. Quite the contrary. After all, if you think of a steady stream of water drops continued long enough, it can wear away the solidest, most solid rock. And that's where I believe our hopes and efforts must be directed. I believe that consciousness, in a paritantric sense, can be the key to shaping our human activities to create this better world. Consciousness, I believe, is an aspect of the overall system that we know very little about, not enough, for sure. Now, in the macrocosmic sense, consciousness applies not just to individual human consciousness and to observations made from our human senses, because, for instance, most, you can go to the next one. Yeah. It's not just humans that have this consciousness. Consciousness is, in effect, all around us. Most dogs know when their masters are coming home, even if they can't see them, or if he comes at irregular times. Species of birds that migrate in flocks follow their leaders over immense distances. They turn and they wheel in the sky in unison. How? Many species of fish can change color like a chameleon, depending on their surroundings. Many other species of fish, eels, salmon, and so on, spend most of their lives in the open ocean, often in particular locations, but always return to spawn in the exact same river and stream where they themselves were hatched. Many experiments show that plants even grow faster when exposed to music or spiritual sounds. But the next example is amazing. Butterflies, monarch butterflies, migrate in North America thousands of kilometers, and they always return to the exact same grove of trees. I've seen them myself in Southern California, in Mexico. It's amazing, in a very small area. Even more amazing, it is not one individual that makes the entire migration. It may take 2 or even 3 generations. Yet it's all done within a season. Now that is astounding, I think. What about this consciousness? How does it work? Well, as I say, I see it as being all around us. The human has the ability to survey the world, receives a perception, and processes that through perhaps conceptual knowledge that he has, practical experience, policies of his society or values of his community, and then he formulates an action which he projects onto the world, which changes the world. Now, all this is done in the same context of consciousness. Animals and plants, of course, act directly from consciousness. They don't have these layers there. So when we carry out our action, there is a different world out there. The person hopefully perceives that as better in some sense than before. But is it really better in a long-term or in a wider framework? Or maybe it's created some other problem somewhere else, for someone else to solve. Consciousness is the overarching factor in this process. It affects the actions and choices of individuals, as well as groups or nations. But I believe that it's at the individual level where the nature of that consciousness is most relevant. For example, if persons have narrowly focused consciousness, perhaps based on short-term interest, greed, perhaps, they'll base their actions and perceptions solely on what immediately benefits themselves the most. On the other hand, persons with a consciousness that they are a part of an all-encompassing system that is perpetual and multidimensional will consider the community, environmental and spiritual factors, as well as their own self-interest in carrying out a plan of action. And I call the latter type of consciousness a systems consciousness. And I think it's clear that such a consciousness is needed by individuals, groups, and nations. And I believe that such a consciousness may well be the key to achieving a better world. The question is, how can such a consciousness be developed, understood, and conveyed to as wide a segment of humanity as possible? Now, here's where systems theory comes in. It has to be brought in, of course, at this conference. Particularly an all-encompassing general systems theory, paritantra in other words, is a way to do this. In my opinion, we're still a considerable distance from achieving widespread appreciation of such a general theory, but there are several ways that we're starting to do it. And let's see how the system theory has evolved. This is a bit of a survey, uneven in its coverage, for which I apologize in advance, but nevertheless, hopefully shows some of the steps and stages of its development that are relevant. Now, the initial thrust, if you like, of human thought that was directed to explaining our world was really occurred when there was quantification of various phenomena and their interrelationships. And this thrust grew to complement philosophical, dialectical, and spiritual modes of understanding. Those have been present since the dawn of mankind, after all. The quantitative measurement of physical things, such as buildings, crops, land, started thousands of years ago in ancient societies and led to the development of mathematics, physical sciences, and so on. And of course, that permitted ever larger and more complex buildings. And of course, it's interesting that most of the larger complex buildings, certainly of ancient times up to relatively modern times, were devoted to religious and spiritual purposes. Of course, a lot of the mathematics and so on and physics went into devising more efficient weapons of war, and that still goes on. It's only recently that the quantification of non-physical systems and their relationships has occurred. And there's a number of researchers that I could have chosen to say, well, here's an initial effort. But I like Vilfredo Pareto. He was an Italian economist whose parents died and left him a considerable amount of money around the 1880s, 1890s, and he moved to Switzerland and lived a life as, in a sense, a thinker and professor without having to worry about an institution to pay his paycheck. And there he is. Actually, he is buried in a village called Seligny, in a very tiny graveyard, which I visited in July, because it's right about 3 kilometers from where my younger daughter now is living, working at the World Health Organization in Geneva. And he was probably one of the first mathematical economists who stimulated a whole movement in quantitative economics and econometrics. Now, in the 1930s, we had Ludwig von Bertalanffy. He was an Austrian biologist. He noticed that there were analogies between biological systems, obviously, but also physical, chemical systems, and he suggested that there could be a general systems laws, set of these laws, that could also apply to human and social sciences. And Bertalanffy contended that one couldn't understand the function of any particular entity without considering other entities and their connections in the larger system of which it is a part. And so he developed his general systems theory in the 1930s, started publishing it in the 1940s, and has a series of books starting in the 60s. Now, another paradigm of systems theory and analysis arose from a concept called cybernetics, which is the study of systems and processes that interact within themselves, okay, and are to some degree self-regulating systems. This also was developed in the 1930s and 40s, and the so-called father of this discipline is Norbert Wiener. He was born in the USA. He was a European Jewish descent, and he was a brilliant mathematician. When we talk about bright, he got his BA in mathematics when he was 14 years old in 1909. 3 years later, he had a Harvard PhD. Unfortunately, in 1918, he applied for a job teaching at Harvard, and they turned him down. Some rumors say that because he was Jewish, it was the reason. But he accepted an appointment instead at MIT, and the rest is history. Now, Wiener also had a philosophic bent, led him to inquire into the social and religious implications of system theory. And there's a couple of his books that I've cited that indicate that to you. Now, there are various other people developing in cybernetics. One particularly interesting one was Stafford Beer. He was an English mathematician who developed management cybernetics for business analysis. And he greatly contributed to the field of operational research and cybernetics generally. And in the early 1970s, he was invited by the government of Chile, which was under the leadership of Salvador Allende at the time, to put his theories to work at a national level. And they called it Project CyberSyn. This is the conceptual framework of it. And they had an actual control room, an operations room with hundreds of telex machines that was the technology of the times, were feeding information and communication to all parts of the country. And supposedly you could then manage the industrial economy in real time. And the goal, of course, was to create a more participative and less bureaucratic society. Unfortunately, some critics feared that the opposite might occur. And in any case, there was a military coup in Chile which put an end to the project in 1973. Other dimensions were added following on. Wes Churchman was an American philosopher. He also contributed to quantitative system theory and analysis. He extended operations research to fields such as management, again, industrial management, city planning, space exploration, my goodness, education, and in later life, peace and conflict studies. And he may have come close to the definition of paritantra when he wrote, quote, that you can see on the screen there. He says, all aspects of the human world should be tied together in one grand rational scheme. Now, the modeling of real-world systems was studied by Jay Forrester, an electrical engineer, spent his entire career at MIT. Believe it or not, he's still there. He's still affiliated with it, not there, at the age of 91. Now, whole world models were popularized, by Dennis Meadows and his collaborators who worked with the Club of Rome on limits to growth and the following things. Now, there's a new approach, however, that came up, a topological approach during the late 50s and early 60s. And it was, the team somehow coalesced at Michigan State University from a number of other places. And they developed a new paradigm based on linear graph theory for their analyses. Now, the question of going beyond that, we had to see how can we extend that already extended physical system analysis to something beyond that, to social, economic, and whatever. Now, initially when I was in the program there, I was interested in optimal control theory for complex systems. Sounds wonderful, a big challenge. The Russians were doing it too. So that was a big spur. However, I found soon that the main employment outlets, my colleagues were getting job offers from Hughes Aircraft and Collins Radio and Raytheon, all the big contractors in the defense and aerospace industries with military connections. And I really didn't want that very much. So I said, why can't we choose the socioeconomic systems as a way to extend it? And we did so. Now, it certainly was a more palatable choice for me anyway. Now, the first area I looked at was travel patterns because they intuitively resemble a linear graph network. And there was also a research program at the university at the time that had an extensive database that I could just sort of pick up and play with. The next one was how to set up the variables, the through variable and the across variable. And we looked at the question of campers flowing to state parks along, obviously, state routes and coming from different origins. So it to not only my surprise, but to other people's surprise, it did work. The next attempt was to look at an economic system. Now here, it was a little more difficult. There have been a lot of complicated econometric models made, which are something like measuring your elephant by a series of equations describing its outside and maybe its structure and what it eats and what it feeds on and so on, but without understanding the exact structure. So getting the linear graph had to draw on data of each industry and how they interacted. And there were only very few models like that available with data. One had been constructed by Vasily Leontiev in the 40s and 50s and his colleagues. So I took at that data, and we had a 3-sector dynamic model over a 5-year period, and were able to demonstrate that a linear graph model could in fact describe it. So I then transferred back to Waterloo, and lo and behold, Prem Satsangi showed up. And he actually wanted to do a PhD in non-physical systems. And we did it, of course, we called it then socioeconomic systems analysis. And he extended the linear graph inter-industry model by several miles, shall we say. He went to a 10-sector model, 10-industry model, and also incorporated 5 regions. Now this would leave anyone tearing their hair, and I think it led us to tear our hair a little bit too. But we were able to get Satsangi a place in Ottawa for, how long was it, Prem? It was several weeks, I think, where he actually mined the data from the statistics available in the capital. And for goodness sakes, the model worked. So the rest, I guess, is history. The kinds of things that I followed on with were transportation works in various other places, tried to apply it to things like regional planning, design of urban projects, environmental management, and it's hard to get a research grant to do that. You really can't. Fortunately, there were consulting opportunities where that had the dual advantage of being able to develop the concepts and the theories, but also the applications that they were getting out where they hopefully would eventually be used. And the other emphasis was on undergraduate programs of, shall we say, more integrated view of society and the environment. And this took place both at Waterloo and at York. Now, of course, in India, as you're, I'm sure, all well aware of how Satsangi has spearheaded the expansion of system theory research. And there we are. Yeah, you can go. Go. Yeah, yeah, there we are. And but not only here, all over the world, literally. We had the Society for General Systems Research starting up in the 50s. Now, of course, has a different title. And of course, Professor George Clear, who is with us today, was the founder of the International Journal of General Systems. And as far as I can tell, has never looked back since. The International Federation of Systems Sciences, Systems Research, sorry, now links over 25 groups of system science people. So there we are. That's a breathtaking human accomplishment, all of that. But have we actually made a better world society as a result? Has the goal of paritantra been achieved? When we view the present state of the world, it's hard to see the benefits of all this work yet. So I think some new directions are needed. We need a new and broader concepts. We need further practical applications. We need to have their benefits be real and be realized by decision makers and the public. And most important, the system's consciousness must be encouraged to become as universal as possible. Now, all of the great contributors noted in the earlier part, nearly all of them came from a background of electrical engineering or some other quantitative discipline, but they eventually articulated a need to incorporate non-quantitative, philosophical, and spiritual dimensions into systems analysis. Now that's what I call systems consciousness. One example is Ilya Prigogine. He is a Nobel laureate in chemistry. He won it in 1977 for his contributions to statistical thermodynamics, of all things. But he contributed to system theory in some of his earlier works. I remember one day in New York at an operations research conference in the late 1960s, sitting with Ilya Prigogine and a few other people at a table over lunch. I just talked about my network theory of travel, and he had just talked about a stochastic analysis, micro-analysis of traffic flows in the same session. Now, the interesting thing is that at the end of the 90s, he wrote a book called The End of Certainty. And what he said, basically, the more we know about our universe, the more difficult it becomes to believe in determinism. Now, another dimension, of course, the spiritual one, is being nurtured here. Professor Satsangi, again, has produced literature on this and has explained an elegant model of man and the macrocosm. And I think the main lesson that we can take from this all, I think we all have to absorb it. There is only one system. There is only one system. And there is only one system. And I think the world would be a better place if this were absorbed by as many people as possible. One system concept, I believe, can be taught. If so, our actions would be less self-centered and more system-oriented. Individual actions done in a better way will lead by tiny increments to a better world. And the cumulative actions of millions and billions of consciousness-motivated people, I think, could really change the world, make a better world. Now, if students and all people do absorb the one system concept, their actions will be less self-centered, more system-oriented. Each individual action done in a better way will lead in tiny increments to a better world. Now, if we think of a beam of white light coming perhaps through the window here, is it a system? System? Of course it is. If we pass that white light through a glass prism, what do we get? We get an infinite number of colors of light. And then we see its systems property. Now each one of us, we are the white light, but we are also all of the colors. We're the source of the light and its sink. Systems paritantra consciousness means each one of us is the one system. Each one of us can change the system. Each one of us is simply linked with everyone and everything. What does this mean? It means you are the system, and you, and you, and I. And all of us, individually and collectively. And the thing is, we must never underestimate what can come from collective actions of millions and billions of consciousness-motivated people, which will lead to a better world. Margaret Mead said, never underestimate the power of a few committed individuals to change the world. Indeed, it's the only thing that ever has. Mahatma Gandhi said, we must be the change we wish to seek. And that, I think, is the way we can truly lead to a better world. Now, I thank you all for being so patient in listening to me today. I hope that each one of you here today will use your talents and insights to help systems paritantra for a better world order and a sustainable world. Thank you very much.